Assalamualaikum. So today, our group will present about our proposed framework, which is Data Privacy Framework for Cloud-Based IoT Devices. My name is Nur Anis Alia, and I will talk about extract of the framework. The integration of cloud computing and IoT has transformed industries like healthcare and smart cities by enabling smarter and scalable systems. But with the growth comes a major challenge, protecting the sensitive data that's constantly being transmitted across distributed platforms. Unfortunately, many existing frameworks are either too heavy for IoT devices, lack proper user control, or fall short of privacy regulations like GDPR. This paper introduced a lightweight, modular privacy framework based on privacy by design. It features dynamic consent management, end-to-end encryption, and blockchain-based identity control. The goal is to safeguard personal data, empower users, and ensure compliance without sacrificing performance or scalability. Next, a brief introduction of our proposed framework. IoT and cloud computing are transforming sectors like healthcare, smart cities, and industry by enabling real-time data processing and automation. However, this also introduces serious privacy and security risks. IoT devices often collect sensitive data and are prone to vulnerabilities like weak encryption, outdated software, and default passwords. On the other hand, cloud platforms face risks like incident threats and regulatory non-compliance. Although regulations like GDPR and PDPA demand strong data protection, most systems work without privacy in mind, that making compliance difficult. New technologies like edge, fog computing, and blockchain offer improvement but add complexity. So, there's a clear need for a unified, lightweight privacy framework that can work in decentralized, resource-limited environments while keeping data secure and compliant.
Assalamualaikum, my name is BINTI and my metric number is 072367. So the rapid growth of the Internet of Things or IoT combined with cloud computing has allowed smart systems like smart cities and e-hub to process data at scale. However, this also introduced serious privacy and security challenges. Most existing frameworks like the Cloud-Based Secure and Efficient Framework or CSEF focus on encryption and mutual authentication, but they often lack user-level control over personal data. Similarly, the Snap4 City platform offered end-to-end GDPR compliant architecture for smart cities, but require complex infrastructure, making it impractical for smaller deployment. Meanwhile, ARM's privacy change purpose but change-based access control, yet it struggles with latency and scalability in real-time IoT environments. Across the study, a common gap is evident. There is no unified solution that offers strong privacy, legal compliance like GDPR, and efficiency suitable for constrained IoT devices. Therefore, our study proposed a data privacy framework tailored for cloud-based IoT system. It integrates lightweight cryptography that makes decentralized access control using blockchain and dynamic consent-based data sharing. Our goal is to protect user data effectively while keeping the system scalable and compliant.
The objective of this paper is to design a security framework that serves as a solution for the security issues in cloud-based IoT devices. The key approach is to implement the 7 privacy by design principles at the start of data flow of any cloud-based IoT systems. The framework must address data leakage, authentication issues, and poor consent awareness, which are often found across cloud-based IoT devices. Cloud IoT systems remain firmly in the crosshairs of serious privacy risk due to the vast volumes of data generated and distributed by intelligent devices with insufficient protection. Fitness trackers are just one example of device that automatically gather personal user health information uploaded to the cloud without proper encryption, violating modern data protection legislation like GDPR. These vulnerabilities put user data at risk for data leakage, unauthorized use, and unaware data sharing. Problem statement. Firstly, end-to-end security in lightweight devices. Many IoT devices operate under tight resource constraints such as low processing power, memory, and bandwidth, making robust end-to-end encryption difficult. Without efficient cryptographic mechanisms, data exchange between devices and the cloud remains vulnerable to interception or tampering. Secondly, data visibility and transparency towards users. Users often lack visibility into how their data is collected, processed, stored, and shared across IoT cloud systems. This lack of transparency undermines trust and prevents meaningful assessment of privacy risks. Lastly, the lack of user-centric data control. Additionally, current IoT cloud platforms frequently overlook user-centric data control design. Users may be unaware of data collection or lack tools to manage consent. Ignoring this principle limits users' ability to make informed privacy decisions, infringing on data sovereignty laws.
I'll briefly explain the methodology used in this research. First, we conduct a comprehensive literature review focusing on IoT privacy and security. It includes latest studies paper, industry report, and legal standards like GDPR, NIST, and ISO. And we also explore common weakness in IoT cloud data flows and the use of privacy enhancing technology, PET, such as blockchain and encryption. Next, we identify key privacy issues like weak authentication, poor data transparency, and lack of user controls. We use frameworks like Solovis taxonomy and NIST to analyze and categorize these threats. So based on those findings, we design a privacy by design framework with three main modules, which is an encryption layer for data protection. We identify management for secure access and user consent policy to give users full control. So to make it practical, we align this proposed framework with international standards. This diagram shows the privacy and security framework for IoT cloud data flow. It's designed with three main layers that work together to secure data, protect user privacy, and follow legal standards like GDPR. So at the bottom, we have IoT device and data collection layer like sensors, smartwatch, and smartphones. So all this collect personal data such as health or location information based on the IoT itself. So because this device have limited security and are connected to the internet, data needs to be protected immediately to avoid leaking, data leakage or hacking. The security and privacy protection layer is the core layer, the main layer that protects the data as it transmits from device to the cloud. So it includes four modules, which is end-to-end encryption, authentication and access control, user access control policies, and also blockchain access management. So for end-to-end encryptions, data is encrypted from the moment it's collected, during transmission, and also in storage. For authentication and access control, it only allow verified users and verified device that could access the data. And for the user access control policies, it allows user to set who can access their data and under what kind of conditions they can access data. And for the blockchain access management, every access is recorded in a secure, tamper-proof ledger to ensure the transparency and the trust. So this layer keeps the data safe, private, and legally compliant during data transmission. Then we have user control and governance layer that give full controls to the user, which it includes three: a consent management, a privacy setting, and activity log. So for consent management panels, it allow or will block the data sharing. A privacy settings interface is for user to adjust who can access what kind of data, and activity log is to track who can access their data. So this ensure more transparency and also user empowerment of their own data. So at the last, the secure data is stored in the cloud storage, which is protected with strong encryption and access rules. So even the cloud provider can misuse the data. So this layer framework provides complete protections from the device to the clouds, while it giving users control over their own data. So it's a combination of technology, legal standards, and privacy tools to create a secure IoT environment. That is the proposed framework we have the
result, I have divided into a few points, and the first one is the framework that was designed to follow privacy rules such as GDPR and give user more access to control their own data in a legal and user-friendly way. This includes dynamic consent, where user can choose how their data can be shared. Two-way encryption, such as ECC, protects sensitive data without actually slowing down small devices. Meanwhile, blockchain is used to manage who can access the data, which adds transparency and builds trust. Tests in areas such as health monitoring and smart cities shows that processing data near the source improves privacy and reduce data exposure. Even though some security features might add some delays, the overall system performs very well and offers stronger privacy compared to traditional setups. In our discussion, we can see that privacy does not need to be implemented later, but must be implemented from the beginning. This is because in a cloud-based environment, sensitive data are always flowing. Usually, a lot of IoT devices have limited power and memory. Therefore, the framework sends heavy tasks like encryption and data analysis to nearby edge devices. This will cause the device will operate faster without any data leaking. One of the biggest advantage is that user can see how their data is being used, which allows to increase the user's trust. Even so, we need to make sure that this system can be easy to understand by the user and the user can understand the risk better. There are some other challenges that we are facing too, such as making sure that all similar devices follow the same privacy rule and improving how different layers of the system can work together better. For future improvements, we also make blockchain and AI tools to be lightweight and scalable even more. In conclusion, the framework that we choose is combining strong privacy practices like blockchain and encryption with user-friendly features which give us both protection and control over the user's data. What makes this stand out is how it balances the legal meetings such as GDPR along with practical use. In other words, it is designed for easy usage to real users. It also works well in real-life situations such as healthcare and smart city, where both of these domains are important in terms of safety and convenience. For the future, the system needs to be tested in a larger scale. Also, plan how to improve the blockchain works, make devices talk to each other better, and simplify the user's interface for the user's understanding better. The last part of our presentation is recommendations. First point is further testing and real-world deployment, where we test the framework in a larger scale IoT environments, such as healthcare and smart cities. This to evaluate performance, scalability, and real-time privacy management. Next, optimization of blockchain and encryption. This to improve blockchain processes and cryptographic techniques so that it can reduce performance overhead for resource-constrained devices. Other than that, user-friendly privacy controls and education. Develop intuitive consent dashboard and control panels so that this can educate users on data privacy risks and management. Lastly, standardization of privacy, policy, and regulatory compliance. This means standardized privacy practices across IoT platforms to ensure ongoing compliance with evolving data protection regulations.